So good morning students. Today in this chapter 3rd, motion in straight line, we are going to discuss one of the most important topic, equation of motion, okay, by integration method. So let's start with the first equation. So first of all we'll find first equation of motion by integration method. Suppose an object start from initial point A. So u is initial speed and v is final speed. A is initial point of motion, b is what? Final. And distance from A to B is s and acceleration a. Okay. So what will be the acceleration? dv by dt. Okay. What is the name of this? dv by dt. The rate of change in velocity is called acceleration. Okay. dv by dt is called acceleration. dv means change in velocity and dt means change in time. That is in differentiate form. Okay. Now students, cross multiply a dt multiply with dv. We define first equation of motion by integration method. So integrating both sides. We did differentiation, we did integration. Okay, in this chapter. Before starting this chapter, we did the basic terms differentiation and integration for solving derivation and numericals point of view. Now integrating both the sides. Integrating both sides. So we know that is the sign of integration. A dt. Initial time is 0 and final time is t. Initial time is t1 is 0 and final time t2 is t. Okay. That is lower limit and that is called upper limit. Initial and final. At that side, we'll also make integration sign and we'll take the limit. Lower limit is initial velocity u and final velocity v. Dt was there, that's why we took time limit. Velocity was there, that's why we took the velocity limit. Understood? Simple, what we did? We started from acceleration, velocity by time. Cross multiply a into dt dv. We defined first equation by integration method. So integrating both the sides. Okay. Now students, a's constants comes outside and we know what was the first formula? Integration of dx is what? X. On account of that, integration of dt is what? T. Limit 0 to t. Integration of dv is what? V. Limit u to v. What is the method for putting limit? Upper limit minus lower limit. So instead variables, we write upper limit t. Instead t, we'll write upper limit t. There will be no change. Then minus sign. Instead t, we write lower limit 0. T minus 0. So how can you put the limit? Upper limit minus lower limit. That is simple method. Instead v, we'll write upper limit v. There will be no change. And then minus sign will come. And instead v, we'll write the lower limit. Okay, we'll write the lower limit u. So v minus u. Simple. What I did? Upper limit minus lower limit. Okay. And finally, what we'll get, students? Look at a into t, at, and v minus u. So transfer u at that side. So what we'll get finally? V equals to u plus at. V equals to u plus at. That is the first equation of motion, where u is initial speed, a is acceleration, t is time taken by object, and v is final velocity. So this is the first equation by integration method. Okay, students. Students will find the second equation of motion. For that, we'll start with velocity. The rate of change in displacement is called velocity. Okay. Velocity having formula displacement by time. ds means change in displacement, dt means change in time. Rate of change in displacement is called velocity. Okay. Now students, cross multiply v into dt, just cross multiply. Here we have ds. Students, we know what is initial velocity, what is final velocity. By the first equation of motion, we can say v is what? U plus at. Here I am going to put u plus at. Instead, I just put u plus at by the first equation. dt as it is and ds as it is. Now students, we have to solve this by integration method. So integrating both the sides. Integrating both sides. integration of u plus at into dt, integration of ds. Okay, now separate the terms. Integration of u dt plus integration of at into dt, separately will integrate. Okay, and integration of ds. U is constant, come outside with respect to time, because this time we have to do integration with respect to time. This is time, okay, and this velocity. So velocity comes outside, and integration of dt will be t. A comes outside, and this is t. T remain inside. Which formula is applicable? N plus 1 upon n plus 1. Okay. And finally, students, what we'll write? Integration of ds is what? S. Look at, students, A is constant, come outside acceleration. This is time. This is acceleration. So acceleration come outside. And here, which formula is applicable? Remember the formula. What is the integration of x to the power n? X to the power n plus 1 upon n plus 1. So t power 1, compare this. So n plus 1 upon n plus 1. Instead n, we are having 1. So 1 plus 1 upon 1 plus 1. Okay, students. And integration of ds is what? S. So finally, u into t, ut plus this is t square by 2 and s. Arrange it proper way. S equals to ut plus half at square. This is the second equation of motion. Where s is displacement, u is initial velocity, t is time, a is acceleration. Look at this velocity, and we have to integrate with respect to time. So velocity comes outside, that is constant, and integration of dt is what? T. A acceleration comes outside, that is constant, and t remains inside, because this is time and that is time. Okay, same physical quantity remains inside and integrate. Different physical quantities, this constant comes outside. So this is n plus 1 upon n plus 1. I applied the formula. And integration of ds is what? S. So you'll get s equals to ut plus half at square. That is second equation of motion. Now students will find third equation of motion. So we'll start with the acceleration. Rate of change in velocity is called acceleration. Rate means time. Rate of change in velocity is called acceleration. Now students, multiply and divide by displacement ds here. So when we multiply and divide by same numbers, we divide by ds and multiply with ds, and there comes dt. So what I did, I multiply with ds and divide by ds. When you multiply and divide with same number, it will not affect the equation. Why we did so? Because that is a formula. Look at what is velocity? Displacement by time. Okay, so this is become dv by ds as it is. Displacement time is become velocity. Now cross multiply. A multiply with ds and v remains with dv. Now students, integrating both sides. Here will make integration sign. Here will also make integration sign. Limit 0 to s. Initial displacement 0, final displacement s. Initial velocity 0 u and final velocity is what? V. This is displacement. That's why we took displacement limit. This is dv's velocity. That's why we took velocity limit. This is displacement, and that is acceleration. Both are separate. If both are separate, this will be the constant come outside, and integration of ds is what? S. We know formula. Integration of dx is what? X. On account of that, integration of ds is what? S. A comes outside. Limit 0 to s. This is velocity, and that is velocity. Same component. V remains inside, and v power 1. So which formula is applicable? This one. What is the integration of x to the power n? X to the power n plus 1 upon n plus 1. So instead we will be having 1 plus 1 upon 1 plus 1, limit u to v. put the limit instead as upper limit s, then minus, then instead as lower limit 0. We'll always put first of all upper limit instead variable, then minus n, and then lower limit. This is v square by 2, limit u to v. A into s, as. 2 comes outside. Instead v, we'll put upper limit v, there will be no change, then minus n will come. Instead v, we put upper limit, then minus n will come, and instead we will put lower limit u. So u square. Okay, now cross multiply. 2s equals to v square minus u square. This is set to be third equation of motion. Okay, we can transfer u square at that side, so it becomes v square equals to u square plus 2s. U is initial speed, initial velocity, v is final velocity, a is acceleration, and s is what? Displacement. So we found all three equations by integration method. Okay, students.